In today's lesson, we'd like to consider probability. It is one of the topics that annoys a lot of students, but it is very, very easy. Now, what is probability? Probability is a study of chance or the likelihood of an event happening. So we say that probability is the study of chance or the likelihood of an event happening. So as we define, probability is the study of chance or the likelihood of an event happening. The next thing for us to consider is an event. An event is a defined occurrence or situation. So you say that an event is a defined occurrence or situation. Now let's consider the following example. An example will be that is scoring a 6 on a throw of a die. Now this is a die, this is a die. We know that it is in a cuboid form, this die, and when you throw it, we score 6. So this is 6, scoring 6 on the throw of this. Probably we have thrown this and then we scored 6. So we say that scoring a 6 on a throw of a die, or probably scoring a 3 on the throw of a die, or any of the numbers on the die. So that's the first one. So the first one, that is scoring a 6 on a throw of a die. This is an example of an event. And then also tossing a coin and landing head up. Now this is a coin. This is a coin, so this is a tail, and then this is the head as well. So here you are saying that tossing a coin and landing head up. So when you toss the coin, it lands head up, and this is an example of an event. And then the last example, probably winning the first prize in a raffle. And all these are examples of an event. So we say an event is a defined situation or occurrence. A particular event is denoted by capital letters. So it can either be A or B or C. So a particular event is denoted by a capital letter. Now the next thing we'd like to look at is possibility. Now, the possibility space is a set of all possible outcomes of a given event. So the possibility space So this is the definition for the possibility space. Now, in the examples that were given, first one was scoring a 6 on a throw of a die. The first one, scoring a 6 on the throw of a die. And we know that the possibility space for the event that is tossing, that is throwing a die, we know that we have 1 all the way to 6. So we have 1, we have 2, we have 3, we have 4, 5, and then 6 as well. So the first one, the examples given, the first one, the possibility space for the first one is 1, 2, 3, 4, 5, 6. That is scoring a 6 on the throw of a die. So the possibility space for the die is 1 all the way to 6. We are saying that the possibility space is the set of all possible outcomes of a given event. Now let's see the second one also. The second one was tossing a coin and then landing head up. Now we know for a coin, the possibility space for a coin either head or tail. So that one, our possibility space, that it can either be what, head or tail. And then the third one, winning the first prize in a raffle. Now the possibility space will be all the tickets available or bought for that particular raffle. That will be the possibility space. So possibility space is a set of all possible outcomes of a given event. Now let's note something. The event is a subset of the possibility space. So an event is a subset of the possibility Now, why are we saying so? Now, the event that we gave in this was scoring 6 on the throw of a die. So you can see that 6, that was the event. And you can see that that particular event 6 is a subset of this. Now, we say that 2 sets, that is A, is said to be a subset of B. If all the elements in the set A can be seen in set B. And clearly, the event of scoring 6 on the throw of a die, we can see it in the possibility space. So that particular event is a subset of this possibility space. Now, the second one, we said that what? Tossing a coin and then the coin landing head up. And clearly, we can see that that head up is seen in the possibility space. Over here, we have head and tail. So clearly, it is a subset of this. And then the third one says that is winning the first prize in a given raffle. The first prize. You can see that the one who won is that particular ticket is part of all the available tickets for that particular draw. The ones that were bought, which were part of that draw. So it is also what? A subset of that. So we know that an event, we say an event is a subset of the possibility space. This is so important, and this will give us the range for probability. Probability is between 0 and 1. When you get there, I'll explain it for you to understand better. Now, I would like to consider the theoretical definition of probability. Now, probability that an event occurs. The probability that an event A occurs is defined as the number of ways in which A can happen, expressed as a fraction of the number of ways in which all equally likely events, including A, can occur. Again, the probability that an event A can occur or happen is defined as the number of ways in which A can happen, expressed as a fraction of the number of ways in which all equally likely events, including A, can occur. Now, the most important thing for us to note is what? All equally likely events, including the A. So in a nutshell, all that we are saying, the probability that an event A occurs, it is denoted like this. So you are saying that this is equal to what? Number of ways in which A can happen or occur all over the number of ways in which all equally likely events, including A can occur. That's the probability that an event A would happen. Number of ways in which A can happen all over the number of ways in which all equally likely events, including A, can occur. Now, in a nutshell, probability is defined as the number of events all over number of sample space. Probability, just the number of events over what? Number of what? Sample space. So the event here is A. And then as we know that this event is a subset of the possibility space. Hence, the highest that the event can go will be the same as our number of S. Now, we'd like to consider the theoretical definition of probability. Now, probability that an event occurs. The probability that an event A occurs is defined as the number of ways in which A can happen, expressed as a fraction of the number of ways in which all equally likely events, including A, can occur. Again, the probability that an event A can occur or happen is defined as the number of ways in which A can happen, expressed as a fraction of the number of ways in which all equally likely events, including A, can occur. Now, the most important thing for us to note is what? All equally likely events, including the A. So in a nutshell, all that we are saying, the probability that an event A occurs, it is denoted like this. So you are saying that this is equal to what? Number of ways in which A can happen or occur all over the number of ways in which all equally likely events, including A, can occur. That's the probability that an event A would happen. Number of ways in which A can happen all over the number of ways in which all equally likely events, including A, can occur. Now, in a nutshell, probability is defined as the number of events all over number of sample space. Probability, just the number of events over what? Number of what? Sample space. So the event here is A. And then as we know that this event is a subset of the possibility space. Hence, the highest that the event can go will be the same as our number of S. Now let's consider this example on the board. A basket contains some identical alphabets, of which 5 are white. So this is the basket that I have over here. So we have white, it contains some white alphabets. It says that 5 are white, 4 are blue, and 7 are green. If one alphabet is taken at random from the box, you find the probability that the alphabet, the first one says is green, second one says that is blue, and then the third one says that it is white. Now, probability we know is what? Number of ways in which that particular event can happen, all over the number of ways in which all equally likely events, including that particular event, can occur. Now, over here, how many white do we have? We are being told it's 5. So let's see. So there's the basket and there's the alphabet in it. Let's see the white ones. We are being told 5. So clearly we can see that the white ones, we have, there's the first one, 1, 2, 3, 4, 5. White ones are 5. And then what again? Blue. How many blues do we have? Blue, we have 4. Blue. So blue, 4. 1, 2, 3, 4. And then the greens are 7. Let's see the number of 7 alphabets that we have over there. 7. So 7 of them. The greens are 7. 1, 2, 3, 4, 5, 6, 7. Wow. So let's see. Now, so over here, what is the number of white balls do you have? Number of white, 5. Now, what again? 4 are blue. So, number of blue balls we are given is 4. And the number of green balls we are being told is 7. Now, probability is number of events over number of what? Sample space. Now, let's find our number of sample space. Number of sample space, everything in it, that is 5 plus 4 plus 7. Now 5 plus 4 is 9 plus 7. This is giving us 16. Why? The total number of alphabets in this, when you count everything here, it is equal to what? 16. So that is what I've added on the board. Now the first one is saying that we should, what's the probability that the alphabet will be what? Green. Now, so probability that it will be green is denoted as P of J. The J is green. Now, is the number of events all over what? Number of sample space. Now, we are saying that the sample space is the set of all possible outcomes of an event. So, let's see. So, number of greens. How many greens do we have here? Number of greens is 7. So, 7 all over the total. The total is 16. Now, so what is the probability that we are going to get a green over here? So all that we do is that the number of greens we have, what's the number of greens we have? That is 1, 2, 3, 4, 5, 6, 7. So the greens, all over the total, it should include the greens as well. So that would be what? The 7 all over 16. Now the second one is saying that what's the probability that it will be blue? So probability that it will be blue. Now definition, number of ways in which the blue can happen, all over the number of ways in which all equally likely events, including the blue, can occur. Now what is the number of blues in this? The number of blues in this is 4. So number of blues all over the number of the sample space. Everything in it is what? Is 16. But what is the number of blues? The number of blues in it is 4. 1, 2, 3, 4. So we have 4 all over the total, which is 16. Now 4 will go into this one. 4 will go into 16. That is 4 times. So we have 1 over 4. And then our third one, number of probability of being white. So PW. Now probability, number of ways in which the event white can occur. So how many ways can the white occur? That is 5. All over the number of sample space. That is everything, which is what? 16. Everything in this is 16. And this is the answers for the question. You see, it is so easy, very tricky. I don't know why students shouldn't choose questions on probability and run to a different question. Now let's consider this example. A fair die is thrown once. What is the probability of obtaining an odd number less than 5? Now we have a die. This is the die. And what do you think would be the sample space for a die? For a die, the sample space ranges from 1 to 6. So our sample space for the die would be 1, 2, 3, 4, 5, 6. And we know our number of sample space is 6 different elements. So we have 6. Now the first one says that an odd number less than 5. So if A is the odd number, now let's list the element for odd numbers less than 5. So odd number, the first odd number is 1. Second odd number is 3. And that is all because you are being told it should be less than 5. So probability that the event A can occur is the number of ways in which A can occur all over the number of sample space. Now, what is the cardinality or the number of ways that A can occur? That is 1, 2. So we have 2 all over the number of ways in which the sample space can occur. That is for 6. And this is just 1 over 3. 2 going 1, 2 going to 6. That is 3. Now, let's see the second one. The second one says that an even number. So let's suppose that B is the event of selecting even numbers. What are the even numbers? That is 2, 4, and then 6. The event, that is 2, 4, 6. So this is the event. Probability, number of ways in which the event can happen, all over the number of ways in which all equally likely events, including that particular event, can occur. So in this case, we know that number of B, the number of the event is 1, 2, 3. So our probability of B, number of ways in which the B can occur, so that is 3. All over the number of ways in which all equally likely events, including the B, which is 6. Now 3 go 1, 3 go 2, so we have 1 all over 2. This is very, very simple. Now let's see the third question. It says that an even number greater than 2. An even number, the event is what? Even number greater than 2. Now let's suppose that C is that event. Even number greater than 2. Now even number greater than 2, the event will be what? That is 4. And it says 2 is not part because it's greater than 2. So we have 4 and 6. Now what is the number of C, or the number of events? That is 2. So probability of the C will be what? Number of ways in which the C can occur all over the total. The total is 6. 2 go 1, 2 go 3. So 1 all over 3. Now let's see the fourth one. The fourth question says that a number between 2 and 5 inclusive. So 2 is part and 5 is part. Now if you are using D to denote that particular event, between 2 and 5. So we have 2, 3, 4, and 5. Remember, 2 and 5 are part. Now, so our number of event, the number of the 1, 2, 3, 4. So that is 4. So probability that that particular event is occurring will be 4 all over 6. 2 go into 4, 2 times 2 go into 6, 3 times. So we have 2 all over 3. Now let's see the fifth one. A prime number which is even. A prime number which is even. We know prime numbers, they have two factors, 1 and the number itself. We know 1 is not a prime number. So the prime number is what? 2, 3, and then 5. But in this question, it says that a prime number which is even. So a prime number which is even is 2. So let's say that F is that particular event. If F is that particular event, then the only element will be 2. In this case, number of that particular event is just 1. How many elements here? Just 1. So the probability that particular event is occurring is 1 all over 6. Number of events all over number of sample space. The number of sample space is 6. I believe you are enjoying it. Probability, that is very, very trivial. Let's consider the next example. Now let's consider this example. The diagram shows 5 discs. So we can see 1, 2, 3, 4, 5. These are drawn to scale, but then all of them should be the same. A disc is chosen at random. Which number is most likely to be chosen? The I, which of them is most likely to be chosen at random? You can see that the 4 is occurring twice, 5 once, 6 once, 8 once. So the one which will be most chosen is 4. So the one with 4. Now, let's see. The 7 says, what is the probability that the number on the disc is even? Now, that particular one, it says, what is the probability that the number on the disc is even? Now, let's list them. So, let's suppose that A is that particular event. So, you can see we have 4, 4, even. But in the sample space, first, let's come out with the sample space. Our sample space will be everything. That is 4, 4, 5, 6, 8. Now, the number of the sample space, 1, 2, 3, 4, 5. That is 5. Now, let's suppose that A is the event of selecting even numbers. So the even one will be what? 4. 4, 6, 8. This is the even. Now, what is the number of A? Is 4. 1, 2, 3, 4. Probability, number of events over number of sample space. So the probability of we selecting the A will be what? Number of events all over the number of sample space. What is the event? Even, that is 4 all over the total number, which is 5. So our probability is 4 over 5. Now let's see the third one. The third one says, what is the probability that the number on the desk is even and a factor of 20? So here we have two conditions. It is even and it should also be a factor of 20. Now, out of the ones which are even, that's 4, 4, 6, 8. Which of these are factors of 20? Clearly, it is these two falls which are factors of 20. So if B is denoting that particular event, now what is the number of that particular event? This is 2. 1, 2. So the probability of that particular event will be what? Number of that event 2 all over the total. How many disks? The sample space. That is what? 5. So we say 2 out of 5. Now let's see the second question, the B. The B says that a disk is chosen at random from the disks with even numbers. First, the sample space was everything including the odd numbers. But here, it was specific with even numbers. So the B, our sample space will not change to only even numbers. That is 4, 4. So 4, 4, 6, 8. 6, 8. This is now our sample space. So number of the sample space, 1, 2, 3, 4. That is 4. What's the question? The question says that what is the probability that the number on the disk is a factor of 20? Now, these are the even numbers. Which of them are factors of 20? So let's suppose that E is that particular event. The factors of 20 is just 4, 4. These two things are factors of 20. So number of that particular event, how many? 1, 2. So probability that is a factor of 20. This is what? Number of events, that is 2. All over the number of sample space, 4. So the 2 go 1, 2 go into 4, 2 times. So we have 1 over 2. That is it. So the second one, the sample space has changed. Why? We want to pick only the disks with even numbers, not all of them. Now let's consider this particular past question. A number is selected at random from the set B, 1, 2, 3, 4, all the way to 40. We should find the probability that it is a prime number. Now, probability is number of events over number of sample space. And we know that an event is a defined occurrence or situation. And then the sample space is the number of ways, is the number of possible outcomes of a particular event. We know that the possibility space is the number of possible outcomes of a particular event. Now, let's see the sample space. So B, we have 1, 2, 3, 4, all the way to 40. So 1, 2, 3, 4, 5, 6, 7, and the last one is ending at 40. Hence, our number of sample space, that's the number of elements in the set B, is 40. And this is the same as the number of sample space. So that is what? 40. Now, the event is that it is a prime number. So you can say that let any capital letter X be the event of selecting prime numbers. Now, so the event X. Now let's list this particular event. We know prime numbers. One is not a prime number. Prime number, they have two factors, one and the number itself. So one is not a prime number. The first prime number is 2. The next prime number is 3. followed by 5. 6 is not, 7 is. 8 is not, 9 is not, 10 is not, 11 is, 13 is, 14 is not, 15 is not, 16 is not, 17. 18 is not, but 19 is. 20, 21 is not. 21 is not, 22 is not, 23 is the next one. 24 is not, 25 is not, 26 is not, 27 is not, 28 is not, 29. 30 is not, 31. 32 is not, 33 is not, 34 is not, 35 is not, 36 is not, 37. And these are the possible prime numbers between 1 and then 40. So what is the number of events over the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? So number of that particular event is 12. So probability that the event X can occur is number of events all over the number of sample space. Now, what is the event? That is 12. What's the number of sample space? We had it to be what? 40. Now, we can leave it like this, or we can still bring it down, reduce it. 4 will go into 12, 3. 4 will go into 40, that is 10. So we have either 3 over 10, or we can change it to decimals, 0.3. So either this or that, any of them. Now let's consider this past question. This was 2020. Now the table above shows 3 classes, JHS1, JHS2, and JHS3 in the school. The 3 classes were combined to select a prefect. What is the probability that the prefect will be a boy? So first we have to know the sample space. So our sample space, that is addition of all the students in the school. So here we have 32, 26, 26, we have 24, so that is 28, we have 44, and then also we have 36. Now when you add all, this is giving us 92. Now the question says that, what is the probability that the prefect would be a boy? So the event is what? A boy. So A, I can say that let X, a capital letter, be the event of selecting a boy to be the prefect. Now we have to know the number of boys in the school. Now the number of boys in the school, let's see boys in the school. So 32, 26, 26. So that is what? 32 plus 26 plus 26. An event is a defined occurrence or situation. Now when you add all this, this is giving us, that is 84. Now the probability that it will be a boy, that what? Number of events all over the number of sample space. And clearly the number of X, that's the number of events, is boys, is what? 84. All over the total is 192. Now 12 will go into 84, that will be 7 times. 12 will go into 192, that is 16 times. So the first one is 7 all over 16. Now let's see the second one. The second one says that a girl in JHS2. Now, so the event, you can say that let Y be the event that the girl, event that the prefect will be a girl in JHS2. So a girl, we have to come to JHS2. This is JHS2. What's the number of girls in JHS2? That is 44. So we have our number of events to be 44. Now, the probability that The girl will be in JHS2. Number of events, that's 44, all over the number of sample space. And what is the sample space? The sample space is 192, the total. Now, 4 will go into 44, that is 11 times. And then 4 will go into 192, this will give us, that is 48 times. So we have 11 all over 48. Probability, number of events, all over number of sample space. Now let's consider this particular example. The table shows the classification of students in the schools. We have they, boarding boys, girls, SHS1, SHS2, SHS3. Now let's say, the first one is if a student is chosen or is selected at random from the school, find the probability that the student is a boy. Now, so a student, we have the student and then boarding student. So that is everybody. The sample space will be everything. That is both the and then boarding student. Now, the sense is if a boarder is selected, remember if a boarder, so hence our sample space will change for the second one. Now, let's see. The first, we know that probability is number of events over number of sample space. So let's find the sample space. So our number of, that's number of sample space. That is all the students in the school, both day and boarding student. So we have 45 plus 40, 45, 40, 60, plus 55, plus 50, plus 35, plus 65, plus 50, plus 70, plus 55, plus 45, plus 30. So when you add all of this, this is giving us 600. So number of sample space is 600. Now let's see, the first question asks, if a student is selected at random from the school, find the probability that the student is a boy. So the first of the event is a boy. So here we can let any capital letter be that event. So we can say that let X be the event of selecting a boy as the school prefect. So our number of events, boy. So let's see, what are the boys? The boys, we have 45, 50, 70. So 45 plus 50 plus 70. But this is only the days. So let's also come to the borders. We have 60 plus 65 plus 45. And when we add all of this, this is giving us 335. Now, the probability that the student selected will be a boy will be what? The number of boys all over the number of sample space. And this was 335 all over 600. And this we can cancel out. When we cancel out, we will get 67 all over 120. So probability, number of events or number of sample space. Now, let's see the beta. The second one says a girl. So you can say that let Y be the event of selecting a girl as the school prefect. Now, number of girls. Here we are being told in SS3, a girl in SS3, a girl in SS3. in SS3 as a school prefect. Now, a girl in SS3. So let's come to SS3. What are the girls? SS3. That is 55, then 30. So our number of Y will be 65 plus 30. A girl in SS3. So a girl in SS3. So the first one, that is 55 and 30. Not 65, but then 55 and 30. And when we add this is giving us 85. Now, the probability, that's the number of events over number of sample space. And what is the event? That is 85. What is the sample space? The total, that's 600. And when they cancel out this is giving us, that is 17 all over 120. So we shouldn't forget a girl in SS3. So you come to SS3, you look for the girls, 55, day student, 30, borders. So addition of all of them, that's 85 all over the total, 600. And this is giving us 17 over 120. Now let's consider the second one, II. Now the second one says that if a border is selected, the first one was if a student, that is everybody, the sample space. But then the second one says if a border is selected. So hence, with the second one, our number of sample space will not change to only the borders in the school. So that will be 60 plus 55 plus 65 plus 50 plus 45 plus 30. Now when you add all, this is giving us 305. Now let's see the first question asked. Says that find the probability that the one is in SS1. That particular person is in SS1. So let's come to SS1. Borders. What are the borders? That's 60 plus 55. So you can say that let probably any variable, probably A, be the event of selecting a border in SS1 as the prefect. So our number of A will be, that is 60 plus 55. 60 plus 55. And this is 115. So probability that A is occurring, that will be what number of events all over number of sample space. So the event 115, the sample space is 305. 305. And when we cancel out this is giving us 23 all over 61. Now let's see the beta. The beta says that a girl. So let's come to the borders. So we can say that let probably be the event of selecting a girl as the school prefect. But we shouldn't forget that it's a border. We shouldn't forget that it's a border. We shouldn't forget that it's a border. So number of the borders that are girls. So let's see borders. This is a column for borders. Then the girls are 55, 50, and 30. So we have 55 plus 50 plus 30. And this 55 plus 30, that is 105. So that is 135. So probability of B, number of events over number of sample space. So the event is 135 all over the sample space. What is the sample space? The sample space is 305. And when we cancel out this is giving us thus 27 all over 21. So probability, that is number of events all over number of sample space. So 135 over 305, this is 27 all over 61. And we shouldn't forget that probability is basically number of events all over number of sample space. Now what is the event? The event is a defined occurrence or situation. And then sample space is a set of all possible outcomes of a particular event. Now let's consider this example. Two fair dice are thrown once. Draw the probability space for the possible outcome. So we are being told that two fair dice. Now let's see the sample space. You know that on a die we have 1 to 6. So let's suppose that this is 1, 2, 3, 4, 5, and then we have 6. Now the second part too, we have 1, 2, 3, 4, 5, and then we have 6. Now, so the sample space, so this is the first die, this is the second die, and then they are being thrown. So the possible event will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Either you score 1, 1, you throw the 2, you score 1, 1, either 1, 2, 1, 3, 1, 4, 1, 5. And here it can either be what 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And then here will be 3, 1. Then move to 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. And here will be either 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and then we have 4, 6. And this can either be what 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. This can be 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and then 6, 6. Now, the I says that you find the probability of getting the same digit. Now, same digit, you can see here 1, 1. So 1 on the first digit, on the first die, 1 on the second die. So you can see the same digit 1, 1. 1, 2 is not same digit. 1, 3 is not same digit. So it's going to be what? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Now let's list the event. So it can either be what 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then we have 6, 6. So this is a possible event. So our number of A, how many do we have? 1, 2, 3, 4, 5, 6, 6. And probability, we know that probability is number of events all over number of sample space. And the number of sample space, you have 1 to 6, 1 to 6. So 6 times 6, 36. So this will just give us, the number of events is 6, and then the number of sample space is 36. Since we go into self 1, since we go into 36, that is 6 times. So we have 1 all over 6. That's the first one. Now let's see the second one. A total score greater than 5. A total score greater than 5. Now let's see total score. Total, that means addition. When you add the two scores on the die, it should be greater than 5. Now 1 plus 3 is 4. It's not greater than 5. 1 plus 4 is 5. It's not greater than 5. So the first one will be 1, 4. That will be 1, 5. 1, 5. The first one will be 1, 5. Because 1 plus 5 is 6, which is greater than 5. And then the next one will be 1, 6. 1 plus 6 is greater than that. Now 2 plus 1 is not, 2 plus 3 is not, 2 plus 4. So that will be 2, 4, 2, 5, 2, 6. Now 3 plus 1 is not 3 plus 2 is not 3 plus 3. So you have 3, 3, 3, 4, 3, 5, and then 3, 6. When you add, it is greater than 5. Now 4 plus 1 is not, but then 4, 2. So you have 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Now 5, 1 is part. So you have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Now the next one, we have 6 plus 1, that is greater than 5. 6, 2, 6, 3, 6, 4, 6, 5, and then 6, 6. So all these events, the sum is greater than 5. So let's see the number of events. How many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So our number of, that is the event B, is equal to 26. So the probability, that will be 26 all over 36. 2 will go into 26, 13, 2 will go into 36, that is 18. So you have 13 all over 18, which is very, very easy. Now let's consider this example. A fair die is thrown 2 times. Construct a table of the outcomes. And the B says you calculate the probability that the I, sum of the outcomes is 8. II, product of the outcomes is less than 10. Then the third one, outcomes contains at least a 3. And then the fourth one says a total not less than 5. So a fair die is thrown twice. So we are going to get, we know that with the sample space, that is 1 to 6, 1 to 6. So that is what we are going to do. So let's do it together. So this is my possible sample space. So clearly my number of sample space over here is 36. 1 to 6, 1 to 6, 6 times 6, that is 36. Now let's see the first one. Says that sum of the outcomes is 8. So the event is what? Sum of the outcome is 8. Probability is number of events over number of sample space. So if A is that particular event, that the sum is 8. Sum is 8. 1 plus 1 is not 8. 1 plus 6 is not 8. Now let's see, 2 plus 3 not 8, 2 plus 5, but then 2, 6 is part. So 2 plus 6 is 8. This is part. Now 3 plus 1 is not part. 3 plus 3 is not part. 3 plus 5 is part. So 3, 5 is part. Now let's see, 4 plus 1 is not part. 4 plus 2, 4 plus 3 is not part. 4 plus 4 will give us 8. Now 5 plus 1 is not part. But then 5 plus 3. 5 plus 3 will give us 8. And now let's see, 6 plus 2 is also giving us 8. So these are the possible sample space. Let's see how many. 1, 2, 3, 4, 5. So our number of events, or the cardinality of the A, is 5. So probability of we getting A is a number of events, which is 5, all over number of sample space, which is 36. Now let's see the second one. The second one says that the product of the outcomes is less than 10. So B, product of the outcomes less than 10. Okay, let's see, 1 times 1 is less than 10. Product, 1, 2 is part, 1, 3 is part, 1, 4 is part, 1, 5 is part. When you multiply, it's less than 10. 1, 6 is part. 2, 1 is part. 2, 2 is part. 2, 3. When you multiply, it is less than 10. 2, 4 is part. 2, 5 is not part. Now 3, 1 is part, 3, 2 is part, 3, 3 is part. So we have 3, 1, 3, 2, 3, 3. 3, 4, because 3 times 4 will give us 12. It's not part. It should be less than 10. 4, 1 is part. 4, 2 is part. 4, 3 is not part. 4 times 2 will give us 12. 4, 4, 60 is not part. Now 5 times 1 is part. 5 times 16 is not part. 6 times 1 is part. So these are the possible events. Now, so our number of B, number of events, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So number of B is what? 17. So the probability of getting B is 17 all over the total. What's the number of sample space? That is 36. Now the third question says that outcomes contains at least a 3. So outcomes contains at least a 3. Let's come to where the 3 are. So you can see 1, 3. So probably, okay, let's say that the event is denoted by M. So the event will be, that is 1, 3. We can see 2, 3 as well. You can see 3, 3. We can see 4, 3, 5, 3, 4, 3, 5, 3, and then 6, 3. That is on this one. Now let's also see on the first part. So we have 3, 1, 3, 1. We have 3, 2. We have 3, 2. And then 3, 3, but then 3, 3 is already there. 3, 4. 3, 5. 3, 6. So these are the events. Probability, number of events over number of sample space. So let's see number of events. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the number of events is equal to 11. Now, probability that it contains at least a 3 is number of events, which is 11, all over number of sample space. The sample space is 36. So we have 11 over 36. Now let's see the fourth one. A total not less than 5. What does it mean? A total not less than 5. Total not less than 5 means that what? 5 and above. Total addition, when you add, you're going to get 5 and above. So 1, 4 is part, 1, 5 is part, 1, 6 is part, 1 plus 1, no, it's not part. This is not part. So this one is not part, this one is not part, this one is not part. When you add, it's not less than 5. So it should be, that is what, 5 and above. Now this one is not part, this one too is not part. And then 3 plus 1 is not part. So let's see how many that we have. We have 1, 2, 3, 4, 5, 6. So 6 are not part. Now all the rest are part. All the rest are part. So probability, number of events over number of sample space. We know the whole sample space is 36. So it will be what? 36 minus 6 all over the 36, which is what? 30 all over 36. And here 2 will go into this, that is 15. 2 will go into 36, that is 18. 3 will go into 15, that is 5. 3 will go into 18, that is 6. So you have 5 over 6. Or probably can use 6 will go in 36 5 times. 6 will go in 36, that is 6 times. And this is the probability. Number of events over number of sample space. Now let's consider this example. 2 fair dice, A and B, each with faces numbered 1 to 6, are thrown together. Construct a table showing all the equally outcomes. So let's construct our table. So we know the faces for a die 1 to 6. So you have 1, 2, 3, 4, 5, and then 6. Now get 1, 2, 3, 6. And the first one, so if this is A and the second one is B, so here it will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Yeah, that's a 6, 5. So this is the first one. Construct a table showing all the equal likely outcomes. So this is the first one. Now let's see the B. The B says that from your table, list with pair of numbers on the two dice for which the sum is 5. So the first one, the sum is 5. Let's suppose that that particular event is A. Sum is 5. When you add the two, you're going to get 5. Now 1 plus 4 is giving us 5. So 1, 4. Now 2 plus 1, no. 2 plus 3, no. 2 plus 3. So 2 plus 2 is 4, but then 2 plus 3 is 5. Now 3 plus 2 is 5. 3 plus 2 is 5. Now 4 plus 1 is 5. And then what again? 5 plus 1, so that's what we have. That is the sum is 5. So 1, 4, 2, 3, 3, 2, and then 4, 1. Now let's see the second one. The second one says that for which the sum is 10. So when you add the 2, you are getting 10. Let's let B be that particular. When you add the 2, you are getting 10. 1 plus 6 is 7, no. 3 plus 4, no. 3 plus 5, 3 plus 6, that's no. 4 plus 1, no. But then 4 plus 6 is 10. So we have 4, 6. When you add this, it's giving us that is 10. Now 5 plus 1, no. 5 plus 3, no. 5 plus 2, no. 5 plus 3, no. 5 plus 5 is giving us 10. Now 6 plus 1, no. 6 plus 2, no. 6 plus 3, no. 6 plus 4 is giving us 10. So 6, 4. These are they. Now let's see the third one. More than 10. So let's suppose that C is that particular event. The sum is more than 10. More than 10. 4 plus 6 is giving us 10. No. It says more than 3 plus 6. More than 10. So 5 plus 5 is 10. No. But 5, 6 is part. 5, 6 is part. More than 10. More than 10. Now 6, 1, no. 6, 2, 6, 4, 6, 5, and 6, 6. So 6, 5, and then 6, 6. That is more than 10. Now let's see the fourth one says that at least a 10. Let's say D is that particular event. At least 10. It means 10 and above. 10 and above. So we can start from 4, 6, which will give us 10. And then here you can have 5, 5. The next one, 5, 6. More than 10. 10 and above. 6, 4. 6, 5. 6, 6. Now let's see the question C. It says that find the probability that the two dice show I different scores. Then the II says same score. So the first one, different scores. So different scores, one the same score. So let's see the same scores and then let's subtract from the whole thing. So that's what 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And it is 36. So when you take this 6 from this, we have 30. It means that For different scores, that is 1, 2, 1, 3, 1, 4, all of them, it is going to be 30. So our CI says that different scores, so the number of events will be 30 all over the total 36. So different scores, one is not part, so 1, 2, 1, 3. So you take all the same thing out, so that will get 30 over 36. Now 6 will go here 5, 6 will go here 6, so you have 5 over 6. Now let's see the second one. The second one says that same scores. And same scores, the event is on 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. So what do you have? 1, 2, 3, 4, 5, 6. So that will be 6 all over 36, which is 1 over 6. Now let's see question D. Let's see our question D. Question D says that find the probability that two dice show, find the probability that the sum of the numbers on the dice is I5. That's the first one. So we know that probability is number of events over number of sample space. Now what is the number of A? How many elements do you have? 1, 2, 3, 4. So that is 4 all over, that's 4. So number of A is 4. So probability of A will be 4 over 36. 1, 9. So that is 1 over 9. Now let's see the second one. It is saying that the sum of the numbers is more than 10. It's more than 10. The II says 10. So for it to be 10, we have 4, 6, 5, 5, 6. So you have 1, 2, 3. So our number of B is equal to 3. So probability of B, number of events over number of sample space. And that's what we have. Now let's see the third one. The third one says that more than 10, and these are the events. 1, 2, 3. So our number of C is 3. So probability of the C, that will be 3 all over 36. Now let's see the fourth one, at least 10. And these are the elements. So our number of D, what do you have? Your 1, 2, 3, 4, 5, 6. So 6. So probability of the D is 6 all over 36. 6 will go 1, 6 will go in 36 times. So what do you have? 1 over 6. That is the probability, which is very easy. Number of events over number of sample space. Now let's consider this particular past question. 3 blue balls. So we have 3 blue balls. So number of B. 3 blue balls, 5 green balls. So number of the green balls are 5. And a number of red balls. So we don't know the number of red balls. So let's suppose that the number of red balls is X. Are put together in a sack. One ball is picked at random from the sack. If the probability of picking a blue ball is 1 over 6. So they've given us the probability of picking a blue ball is 1 over 6. We define the number of red balls in the sack, which is X. Now, probability is number of events all over number of sample space. Now, what is the event? A defined occurrence or situation. So let's find the number of sample space. So number of sample space, addition of all the balls, which is 3 plus 5 plus X. And this is just 8 plus X. That's the number of sample space. Now, the probability of picking a blue ball, we're given to be 1 over 6. Now, what is the probability of picking a blue ball? That's the number of events all over number of sample space, and this is 1 over 6. Number of blue balls, what's the number of blue balls? It's 3. So you have 3 all over the number of sample space, which is 8 plus X, and this is equal to 1 over 6. So from here, we can do cross multiplication. And when you do cross multiplication, we get 3 times 6 equal to 1 times 8 plus X. And 3 times 6 is giving us 18 equal to 8 plus X. We want to find X. So we have 18 minus 8 equal to X. Therefore, our X is equal to 10. So we have X to be equal to 10. Hence, the number of red balls. So the first one, therefore, number of red balls is what? 10. That's 10. Now let's see the second one says that the probability of picking a green ball. So the second one, the probability of picking a green ball. We know it's what? Number of the green balls all over number of what? Sample space. Now how many green balls do you have? 5. And what is the sample space? The sample space is, that is 8 plus x. So 8 plus x, what is the x? X is 10. So this is 5 all over 18. So number of events all over number of sample space. And this is very, very trivial. Don't forget to get a copy of the books that you are seeing on the screen to give you a very firm foundation in mathematics. It's having a whole lot of questions to help you be a very good mathematician, to understand the principles very, very well. Try and get a copy. Now let's consider this particular example. A box contains 25 balls of which y are red. So what do you have? The number of balls that we have here is 25, of which y are red. So number of red balls is giving us y. Number of red balls is y. But we are being told that the balls over there is what? 25. So number of balls, that is 25. And out of this, y are red. If a ball is selected at random from the box, what is the probability that it is red? So with the first one, the probability that it is red, P of R, we know it's what? Number of events all over the number of sample space. That is y all over 25. So the total number of balls is 25, y are red, so we have y all over 25. Now let's see the second one. When 50 more balls of which 7 are added, 50 more balls of which 7 are added, hence our number of sample space. The first one was 25, but then we've added 15 more, and this is just 40. Now we are being told that 7 are red, so number of red balls now. Number of red balls now. Previously it was y. Now we have added 7 to 8. So our number of red balls becomes y plus 7. Now we are being told that the probability of selecting a red ball becomes 5 over 8. So the probability of selecting a red ball is now 5 over 8. Now, probability is number of events over number of sample space. So number of events all over number of sample space. This is equal to 5 over 8. Now what's the number of events, which is y plus 7? Number of the sample space is 40, equal to 5 all over 8. Here we can cross multiply, or the 40 can just go here. So you have y plus 7 equal to 5 over 8 times 40. Now 8 will go into self 1, 8 will go into 45 times. Y plus 7, 5 times 5, that is 25. So we have our y to be 25 minus 7. So 25 minus 7, and this is just giving us 18. So that is our y. Now the question says that find the number of red balls altogether in the box. Hence, the number of red balls altogether in the box, we know it's what? Y plus 7. So number of red balls. Number of red balls all together, you know, it's y plus 7. So 18 plus 7, which is 25. So the number of red balls is 25. Now let's consider this question. A box contains 40 identical decks, which are either red or white. If the probability of picking a red deck is 1 over 4. So probability of picking a red deck, we are being told, is 1 over 4. We should calculate the number of white decks. Now we know that probability of a red deck, that's the number of red decks all over the number of sample space, and this is equal to what? 1 over 4. A box contains 40 identical, so it means that our number of a sample space is 40. Here we can find number of red balls. So our number of red discs, that will be 1 over 4 times 40. Yes, 40 times 1 over 4. Now 4 will go here 1, 4 will go here 10. So our number of red discs is 10. Now the question says we should find the number of white discs. Now the number of red discs plus the number of white discs is equal to what? 40. But you know number of red discs plus number of white discs is equal to 40. Now number of red discs is 10 plus number of the white discs equal to 40. Hence our number of white discs equal to what? 40 minus 10, and this is what? 30. This is 30. Now let's see the second one. The second says that red discs that should be added such that we should calculate the number of red discs that should be added. So we can say that let X be the red discs added. Hence, our new number of red discs will become what? 10 plus X, because number of red discs was 10. So the number of new red discs will be what? 10 plus X with respect to the second one. Now we are being told that the probability of picking that red disc is giving us 1 over 3. So this will be what? 10 plus X all over the total. But we shouldn't forget that the total will not, because X has been added, will also be what? 40 plus X equal to 1 over 3. So the number of sample space will increase by X because the red balls has increased by X. Here we can do cross multiplication. So you have 3, 10 plus X. Cross multiplication equal to 40 plus X. 3 times 10, 30. 3 times X, we have 3X equal to 40 plus X. We want to find X. So this is 3X minus X. This is going here equal to 40 minus 30. Now 3X minus X, this is giving us 2X. 40 minus 30, this is giving us 10. We want to find our X. So 2X over 2 equal to 10. All over 2 going to 10, 5. So the number of red balls which should be added so that the probability will be 1 over 3 is 5. Now let's consider this example. In a game, a fair die is rolled once and 2 unbiased coins are tossed once. Remember, it is 2 unbiased coins are tossed once. So the coins, the sample space for the coins, you know, head and tail. So it is 2 of them. So you have head and tail. Head and tail. So for the coins, for the 2 coins. Now, so here, the possible event to be either HH, HT, TH, and then TT. So this would be the possible events. Now, so this one and a fair die, the die is what 1 to 6. So for both, the sample space becomes we have 1, 2, 3, 4, 5, 6. Now, so the first one, that is HH. We have HT. We have TH. and then we have TT. So the last part can be cleared. So the samples, the event here will be H1, we have H, H2, H, H3, H, H4, H, H5, H, H6. That's the first one. The second one, we have HT1, HT2, HT3, HT4, HT5, HT6. Now, the next one will be TH1, TH2, TH3, TH4, TH5, TH6. Followed by, we have TT1, TT2, TT3, TT4, TT5, TT6. So there's a possible sample space. Now, what's the question asked? What is the probability of a head, a 3, and a tail? So a head, a 3, and then a tail. Now let's see, a head, a tail, and a tail. This one is there. A head, a tail, and a tail. We have 2. So if A represents such event, and the possible event will be what? HT3, that's the first one, TH3. These are the possible, because we should have a head, a tail, and then a 3. And these are the only ones. But here we have 2 tails, it's not part. A head, a tail, and then a 3. So our number of A, the number of elements that are in set A, 1, 2, 3, 1, 2. That's just 1, 2, 2 elements. So the probability of that A is 2 all over the total, the sample space. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 2 over 24. Now 2 going to 7, 2 going to 24, that is 12. So you have 1 all over 12. This is very, very easy. Let's consider the next. Now we know that probability of an event A occurring is defined as the number of ways in which A can happen, expressed as a fraction of the number of ways in which all equally likely events, including A, can occur. So the probability that A would happen is equal to what? Number of ways in which A can occur or happen all over the number of ways in which all equally likely events, including A, can occur. Now, we know that the number of ways in which A can happen, this is a subset of the sample space. That is, as the event is a subset of the possibility or the sample space, the numerator of this fraction is less than or equal to the denominator. Why? The number of ways is a subset of the possibility space. Hence, for any event, let's suppose for any event A, the probability of A is greater or equal to 0 and less or equal to 1. Now, if probability of A is equal to 1, then we say event A is certain. to happen or occur. If it is equal to 1, then we say the event A is certain to occur. Now, if the probability of A is equal to 0, then we say event A is not certain to happen or occur, or it is what? That particular event is impossible to happen. Now also, if the possibility space has only n different possible events, that is, we have A1, A2, A3, all the way to AN, then the probability of A1 plus probability of A2 plus probability of A3 all the way probability of AN, we say this is equal to 1. So that is if in a particular event we have A1, A2, A3 all up to AN of the same experiment. We shouldn't forget. So if the possibility space has only n different possible events of a particular experiment, then we say that A1, A2, A3, AN, that is probability of A1 plus probability of A2 plus probability of AN, A3 plus probability of AN, all is equal to 1. And this, we can rewrite this in a summation form. Summation I from 1 to n P of AI, and this is just equal to 1. So when you add all the probabilities of a given experiment, then we say that it is equal to 1. Now let's consider. Now let's look at the probability that an event does not happen. Now, if in the possibility space of n equally likely occurrences, the number of times an event A occurs is R. So the possibility space is n, and then A is occurring R times. Remember, this R is out of the n. Then there are n minus R occasions when A does not happen. Now, the total is n, and then A has occurred, that is R times. Then the number of times that A would not occur will be what? The n minus the R. That is subtracting R from the n. That's the number of occasions that the A would not occur. Now, the event A does not happen is denoted by A, and then we have a dash on top, and it's read as not A. Hence, probability that an event A would occur, probability that an event A would occur, what do you think it would be? Number of ways in which A occur all over the number of ways in which all equally likely events, including the A, can occur. So the number of events, that is the number of events all over the number of the sample space. Now the number of times that the A is occurring is R. So we have R all over the number of times the sample space, that is n. Now, probability that A does not occur is the number of ways in which the event occurs all over the number of ways in which we have the sample space. Now, what is the number of times that A is not occurring? That is n minus R. So we have n minus R all over n. This is what we have. But then we know that if you have A plus B all over C, this is the same as A over C plus B over C. So hence, this is the same as n over n minus R over n. Remember, this is P of A naught. Now, what is n over n? N over n is 1. Minus what is R over n? R over n is the same as what? Our P of A. So this is P of not A. Clearly, this can come here. So we have probability that an event A occurs plus the probability that an event does not occur, this is equal to 1. Let's note that the probability that an event occurs plus the probability that an event does not occur is equal to what? 1. Remember, it should be of the same experiment. So from here, this can move here and we'll come to this very important. So we have P of A plus P of not A. This is equal to 1.